Good morning, children. Now we will proceed to the next chapter, that is chapter number 10, measures of dispersion. Previous chapters were dealing with measures of central tendency, in which you have basically studied how to find out the averages of a given series. Now averages, as you have done earlier, that gives you the central value around which all the values revolve, or they are spread along with the central value. So averages, they give you the central value basically, but that does not give you the correct picture of the variability of data, or how the data are scattered or spread, right. So central value gives the average, but the scatteredness or dispersion of the value, that means how the values are spreading from which figure to which figure, what is the trend of dispersion of value, that is not clear with the average. So for this we have a better measure which is known as measure of dispersion, that tells you how the data or how the series is dispersed or scattered, or you can say spread, right. That will give you a better picture. Now what does this dispersion mean? Dispersion means distance from the average. As I told you, average is the central value, and how much the data is spread away from the central value, that is dispersion. So distance from the average is called dispersion. What is the distance of data from the average? Now for example, if one series is 49, 50 and 51, in this case mean is 50, average of these three figures is 50, and here items are close to mean. 50 is the mean here and items are very close to it, one is 49 and one is 51. Now if we take the second series 10, 60 and 80, the mean of these three figures is again 50, but you can see here, as the figures were close in the first series, in this case figures are far away from mean. Mean is 50, the figures are 10, 60 and 80. All three figures are far away from mean. So items are far away from mean. So in these two cases you say that mean is same, mean is 50, but the figures are scattered in different manner, right. And if we calculate only mean and we make the analysis on the basis of calculation of mean only, our analysis will not be complete, because this will not be clear that how much the series are scattered or how much the data is scattered, right. So for this purpose we have to calculate dispersion. So dispersion means distance from the average. This will give you a better picture. Now in this case, when we have taken this example, you can see inequalities are smaller in first series. Dispersion is also smaller, because inequalities are smaller in the sense that they are very close to each other, and dispersion or scatteredness is also smaller, because that is ranging from 49 to 51 only, right. So in this case inequalities are smaller in first series and dispersion is also smaller. Dispersion indicates the extent of uniformity. So from this we conclude that dispersion indicates the extent of uniformity. That means to what extent the figures are uniform, to what extent they are close to each other, or to what extent they are scattered or they are away from each other. So this way dispersion indicates the extent of uniformity. Uniformity and degree of variation are inversely related. Degree of variation means how much they vary, how much the data vary, that is degree of variation, and uniformity means how much close they are or how much uniform they are, and both uniformity and degree of variation are inversely related. They are opposite to each other. More the uniformity, less is the degree of variation. If the figure is more uniform, they are close to each other, there is less variation. If there is less of uniformity, there is more variation. So uniformity and degree of variation are inversely related. Variability means how the observations of the set are scattered around average. That means how the data are scattered around average, that shows the variability. In this case, variability is less because data are close to average. In this case, variability is more because data is far away from average. Got it? So this way, dispersion are very useful in measuring degree of inequality. So in this way, because of all this, you can say that the degree of inequality or the degree of variability we can measure with the help of dispersion. Now, for example, if there is the data given to you, different income groups and number of households are given to you. Income groups and number of households are given to you in each group. Then you can easily find out with the help of measures of dispersion, you can find out what is the inequality of income. Whether all the households are getting almost same income or very close to each other, or whether the data is in such a manner that shows a vast inequality of income. So in this way, measure of dispersion will give you a better picture. Average income you can calculate with the help of measures of central tendency, but how much inequality in income is there, that can be calculated with the help of measures of dispersion, right? Now, after understanding the meaning of dispersion, we come to objectives of dispersion. That means how dispersion is helpful to us. What is the objective of learning dispersion? To determine the reliability of an average. When you study dispersion, that gives you an idea whether the average what you have calculated, that is reliable or accurate or not, because dispersion is the scatteredness of the data and average is the central value or the mean. So with the help of dispersion, you have an idea that what is the range of your data and what is the central value. If the central value is, you can say, correct according to the range or not, that we can know with the help of dispersion. Second objective, to compare two or more series with regard to their variability. As I have done here, we can compare the series with regard to their variability, how much variable they are, how much unequal or how much scattered they are. So